Let's get to know what is differential equation. A differential equation of nth order is said to be linear if it can be expressed in the form of a naught d to the power of ny over dx to the power of n plus a1 d to the power of n minus 1 y over dx to the power of n minus 1 plus a n minus 1 dy over dx plus a n y equal to fx, where the coefficients a0, a1 until an in which an not equal to 0 and fx are functions of x. If there is at least one of the coefficients which is not a constant, then the equation is called linear differential equation with variable coefficients. In this part, we concentrate on different equations of second order. The first equation is a homogeneous, while the second equation is a non-homogeneous equation.
Next is problem description. Differential equations have two types which are homogeneous and non-homogeneous. The problem for the equation given is a case of the non-homogeneous differential equation. Here is the general form of a non-homogeneous differential equation, where fx is a non-zero function. In order to solve a non-homogeneous differential equation, two methods can be used, which are method of undetermined coefficient, which is yc, or variation of parameter, which is yp.
We move to method part. In this part, we can learn how to solve the equation in differential equation of second order. Let's get into it. Next, we go to see the solution for question 4. The question asks to determine the equation of motion for an undamped system at resonance governed by second derivative of dy over dt plus 9y equals 2 cos 3t, and sketch the solution. We can have the characteristic equation m squared plus 9 equal to 0, and we got the complex roots m equal to plus minus 3i. Thus, the complementary function is yc equal to a cos 3t plus b sin 3t, where a and b are constants. Given that fx equal to 2 cos 3t, thus the particular integral is in the form of yp equal to t power of r open bracket m cos 3t plus n sin 3t close bracket. Choosing r equal to 0, and we got yp equal to open bracket m cos 3t plus n sin 3t close bracket. The terms of m cos 3t and n sin 3t in yp is correspond to a cos 3t and b sin 3t in yc. So the choice is inappropriate. Choosing r equal to 1 instead, and we got yp equal to t open bracket m cos 3t plus n sin 3t close bracket. This time, none of the terms in yp is corresponds to a term in yc. Next, we go to differentiate yp using product rule, and we got the first derivative of yp. The next step is we differentiate the first order of yp, and we got the second derivative of yp. Substituting the result into second derivative of dy over dt plus 9y equals to 2 cos 3t, the original equation. Then we got 3 open bracket 2n minus 3mt close bracket cos 3t minus 3 open bracket 2n plus 3nt close bracket sin 3t plus 9t open bracket m cos 3t plus n sin 3t close bracket equal to 2 cos 3t, which reduced to 6n cos 3t minus 6m sin 3t equal to 2 cos 3t. We equating the coefficient of cos 3t and sin 3t, and we got m equal to 1 over 3, m is equal to 0, and the required particular integral is yp equal to 1 over 3 3t sine 3t. Hence, the general solution is y equal to a cos 3t plus b sine 3t plus 1 over 3t sine 3t. Next, we differentiate the general solution to find the y prime. Y prime is equal to negative 3a sine 3t plus 3b cos 3t plus 1 over 3 sine 3t plus b cos 3t. Next, we substitute y open bracket 0 close bracket equal to 1 to obtain value for a into equation y. Hence, we got the value for a is 1. Next, we substitute y prime open bracket 0 close bracket equal to 0 to obtain value for b. Hence, the value of b that we got is b equal to 0. The last step is we substitute the value of a and b into our general solution. Finally, our general solution that we got is y equal to cos 3t plus 1 over 3t sine 3t.
For the result, since we choose question number 4, it requires us to find the differential equation using second order with case number 3, where it is involved cosine equation. In order to obtain the answer for that question, we have to find the value of yc and yp, and then we have to combine it into the general form of the non-homogeneous equation.
As have been said before, ordinary differential equation is practically important for an engineer so that he will be able to model physical problems using mathematical equations. According to that, the two laws have been formed in this equation. The first well-known law is Newton's law of cooling. State that the rate of cooling of an object is proportional to the difference between its temperature and the ambient temperature. This law expresses a fact about the temperature of an object over time, and we express the temperature of the object at time. The second well-known law is Maxwell's equation. It is a coupled set of partial equations that, together with Doran's fourth law, to make local statements and evaluate Maxwell's equation at some point, one can recast Maxwell's equation in their differential form.
For the conclusion, in this case study, our focus only on linear non-homogeneous differential equation of second order. We were about to determine the technique in solving linear non-homogeneous differential equation of second order by the method of undetermined coefficient and variation of parameter. Throughout the case, we were able to solve the equation and understand the key of the concept. We also can obtain the pattern to solve the complex problem.